ESS Intro to Resources Part 4 will continue an examination of the dynamic nature of resources. The status and economic value of natural capital is dynamic, and this movie examines the factors that influence the status of natural capital. The significant ideas are the renewability of natural capital has implications for its sustainable use. The status and economic value of natural capital is dynamic. Here is the outline of all the available movies for the Intro to Resources unit. Use this outline to find the movie you need for review. This movie is focused here, and it's the second movie, the second of two, that look at the dynamic nature of resources. Here's the IB syllabus statement that drives this movie forward. The concept of a natural resource is dynamic. The status and market value of natural capital varies regionally and over time and is influenced by cultural, sociopolitical, economic, environmental, and technological factors. Examples include cork, uranium, and lithium. In working to explain the dynamic nature of resources across time and space, here are the factors that influence the dynamism, the status of resources. There are ecological influences, economic influences, technological, cultural, sociopolitical, and environmental. Now, I covered ecological factors in the last movie, so I will start this movie with the economic factors that influence resource availability. The economics of natural capital is complex. One could study the economics of natural capital for a PhD degree. To keep it simple, the economic dynamism of natural capital hinges on supply, the availability, and demand, the degree to which people use the resource. On the supply side, this depends on the rates of growth, rates of harvest, the markets where the natural income is sold, the price in those markets, and technology. In Part 3, I spoke a lot about rates of growth and ecological availability. Now, the economics of natural capital is also influenced by demand, the price, the need, alternatives, and population size. The size of a population in a location fuels demand. Here is a graph showing the price of gold over time. The price of natural capital is influenced by both supply and demand. On the supply side, if the harvest of gold increases due to new technology, then the price would go down. On the demand side, if the price goes down because of greater availability, the demand will increase. Or if the cultural interest in buying gold jewelry in India were to decrease, the price of gold would decrease. Here is a graph showing the price of wheat over time. Wheat is renewable natural capital. The price of natural capital is influenced by both supply and demand. Wheat supply depends on agricultural productivity, net primary productivity, which is influenced by rainfall, outbreaks of pests, and temperature on a yearly basis. But supply and in turn price also depends on the input costs to the farmers. The price of wheat increased in 2010 because oil prices increased. Industrial agriculture requires a lot of fossil fuel. When oil prices increased, so did the price of food. Demand for wheat as a source of food is consistently strong, but demand will be influenced by the price. And demand could also be influenced by the size of the population that creates the demand. Here is a graph showing the price of oil over time. Oil is a non-renewable natural capital. The price of natural capital is influenced by both supply and demand. The demand for oil across the globe is strong, but the extraction of oil from the ground varies. This is the supply. The supply varies, often for political reasons or maybe social reasons, conflict or war. If political events in one of the major oil exporting countries in the world reduced the extraction, the price of oil will rise. This is a graph of oil reserves over time, and it suggests that the amount of oil in the ground over time has increased. And you might wonder, But oil is non-renewable. There is a finite supply, so how could reserves increase over time? The explanation for this graph is complex, but it hinges on the price of oil. When the price of oil is high, oil companies are willing to look harder or dig deeper to find oil. When the price of oil is high, oil companies are willing to extract oil from rock that had very little oil in it. Thus, awkwardly, while oil reserves are finite across the globe, we don't really know how much is there, and the price per barrel determines what we consider to be known reserves. If the rate of cutting trees from a forest increases, the supply of wood increases, and the price would come down. However, if we take too much, the supply of wood may become scarce, and the price would come up. As populations grow, the demand for resources increases, and this causes prices to rise. But more significantly, this creates situations where the harvest of resources is not sustainable, as you can see on the right. As populations grow, there is increased pressure to extract resources from the environment. Meat and fish have become increasingly expensive. As well, meat and fish are food sources derived from higher trophic levels. Thus, the costs of meat and fish will naturally be higher. When the price of food increases, it becomes less available to many people in the world. With respect to agricultural natural capital, there may be demand, but the price may make food unavailable to people. Now let's look at how technology influences the status of natural capital. Technology can change the rate of harvest. The rate of whale harvest with a handheld harpoon was much less than the rate of whale harvest with modern harpoon guns. The rate of fish harvests with certain forms of technology is less than with other forms of technology. New technologies increase the rate of harvest, increase the output. For renewable natural resources, increasing the rate of harvest increases the likelihood that the harvest exceeds the natural rate of replacement. This is an unsustainable practice. Technology affects rates of extraction, thus influencing price, further influencing rates of extraction, possibly leading to shortages. New combustion engine pumps, as we can see on the right, extract groundwater for irrigation. The rate of extraction is thousands of times greater than older forms of technology, as we can see on the left. While groundwater is a renewable natural resource in the IB syllabus, its rate of replacement is slow, so careful management is required. When extraction rates exceed replacement rates, the resource is being used in an unsustainable manner. This is a diagram of an irrigation pump using a combustion engine that burns fossil fuels. Irrigation has helped triple agricultural productivity over the last 75 years, but the groundwater natural capital everywhere in the world is shrinking. People are not managing their groundwater natural capital very well. Technology such as dam building, or the building of sophisticated networks of canals, has made water available to locations that historically had no access to water. But the damming, or diversion of water from rivers of the world, has changed the nature of surface flow, has changed the hydrological cycle. Groundwater and surface water are both extracted at high rates for irrigation of agricultural crops. With irrigation water, we can grow food in locations that would otherwise not naturally grow food. But our rates of extraction of water exceed the rates of replacement. So much water is extracted from the Colorado River that by the time the river reaches the ocean, there is no water left. Historically, cork was used in the wine industry to stopper bottles. Cork is a renewable resource harvested from trees, and its status as a resource is on the decline. Changing technology and cultural preferences for aluminum screw-on caps have changed the status of cork. Uranium is a non-renewable resource whose status changed during World War II. Nuclear weapons and nuclear power were technological developments that changed the status of uranium. But the 3 Mile Island leak in Pennsylvania and the Chernobyl reactor meltdown in Ukraine were two environmental disasters that slowed society's interest in nuclear power. But nuclear power does not release any greenhouse gases, so there is new political will to bring nuclear power back. Lithium is a non-renewable resource whose status as a resource, unlike that of cork, has increased. Lithium batteries have high charge density and they are rechargeable. Lithium batteries will be used in electric cars. As well, lithium batteries are now very small, serving in watches, phones, cameras, and other portable consumer electronic items. Lithium batteries are expensive, an economic issue that would limit the status of lithium. If you've wondered about deforestation and why more of the world's forests are going down rather than coming up, technology, in combination with population pressure, societal demand, is your answer. In the photo on the left, we can see miners digging minerals out of the mountain by hand. In the photo on the right, we have a modern copper mine that machines have dug. The rates of extraction of non-renewable resources have increased over time. And while the extraction of non-renewable resources is always an unsustainable proposition, environmental damage, as you can see on the right, has become a bigger problem. Technology not only alters rates of extraction, but it changes the resources we use. Technology serves to introduce new resources that replace old resources. At one time, people used whale oil to light lamps. Whale oil was a renewable natural resource. Whale oil was replaced with fossil fuels, coal at first. Today we light our homes using non-renewable fossil fuels, but there's a cost, and that's pollution. The pollution that comes with our use of fossil fuels is called an externality, which is a cost, sometimes a benefit, but a cost that in this case affects society, often a cost that the society did not choose to incur. The pollution that results from our use of fossil fuel is causing environmental degradation. It's a degradation that society is not accounting for. Every time we use fossil fuel, we should be paying money that is used then to prevent or clean up the pollution. The cost of cleaning up the excess carbon dioxide released from fossil fuel combustion should be built into the price of the fossil fuel, but it's not. Now, we could be using dung as fuel or wood as fuel instead of fossil fuels because neither of these increase the carbon dioxide in the atmosphere. That's because dung and wood are composed of plant matter that takes up the carbon dioxide during photosynthesis. Dung and wood are considered carbon-neutral energy sources. Furthermore, dung and wood as energy sources are renewable. But using dung or wood is dirty and inconvenient. Most modern societies use non-renewable fossil fuels to provide energy, to cook our food, heat our homes, light our lamps. And along with fossil fuels comes pollution, climate change, an externality that we're not accounting for in the cost of the fuel. Maybe energy from wind turbines or solar voltaic cells will someday replace fossil fuels. Theoretically, these new technologies will have to replace fossil fuels someday, as the supply of fossil fuel, as a non-renewable resource, is finite. It is interesting how new technologies replace old ones, often with negative environmental consequences. In India, the clay cup was used for centuries, and when the tea was finished, the cup was thrown down on the ground, only to become part of the soil as it broke apart. The clay cup has been replaced with plastic. It's cheaper and easier to transport, but plastic cups now litter the landscape and wash into the ocean. Historically, the burlap bag, made of renewable jute or sisal fibers, was used to transport goods. Plastic has replaced fiber, with serious environmental consequences. Here is a graph showing the demand for oil-based polymers in China over a 9-year period. Plastics made from fossil fuels cause environmental degradation, but plastics are cheap and light. Plates and cups made of pressed leaves as a renewable, degradable resource have been replaced by styrofoam with environmental consequences. And lastly, As we look at the impact of technology on the status of resources, consider gene technology. Many of the world's crops are now genetically modified, corn and soybean particularly. Gene technology has increased yields and has increased the price of food. As well, genetically modified foods, GMOs, have raised ethical concerns. Genetically modified foods have been accepted more in some cultures than others. And that brings us to take a look at how culture influences the status of resources. I've already mentioned many examples of how culture influences the status of a resource. Consider cultures that eat rice. Rice is an important part of their culture, and these cultures are found in locations that can grow rice. So there is an inherent relationship between cultural choice of food and ecological availability. The demand for some resources varies by culture. The value of resources, including price, will vary by culture. Resource availability influences the development of cultural interest in certain resources. In other words, there is often an inherent relationship between cultural choice and ecological availability. Every culture has its preferences with respect to certain resources. And the cultural attachment to certain resources can be very strong. The Atlantic bluefin tuna is an endangered species, but has yet to be listed on CITES because of politics. Japan's cultural interest in tuna has been influential in keeping the bluefin available for hunting. Despite declining storages of fish and whale in the world's oceans, cultural habits persist over time. Due to prevailing religious norms, most Indians are vegetarian. This cultural phenomenon influences the status of onions and potatoes in India and influences the status of meat. But vegetarianism has huge environmental consequences because Indians, a large number of people, on average eat lower on the food chain. The environmental damage is less. The ecological footprint of India is significantly less than if it were a culture of meat eaters. Consider how the status of spices and salts have changed over time. Historically, spices and salt were sought after everywhere for curing meats, preserving foods, not for flavor. Today we have refrigerators to keep our foods fresh, so spices and salts have become associated with cultural preferences for various flavors. And consider how the status of silk has changed over time and has been replaced by cheaper nylons. Now, silk is a renewable resource, while nylons are an oil-based product, a non-renewable product. And the status of gold has changed over time. Few of us today own a lot of gold, except in India, where gold remains a primary form of wealth for families. The status of rhino horn or ivory has changed over time, especially as the renewable resources from which horn and ivory come have been over-harvested. Certain cultures put more demand on these resources than other cultures. Cultures in the Middle East demand horn, while cultures in East Asia demand ivory. The demand for horn and ivory has placed the rhino and the elephant on the endangered species list. Now, let's look at the socio-political influences on the status of resources. Conflict, war particularly, changes the availability of resources to the societies involved. Food production slows during a crisis, and poor people are immediately disadvantaged by conflict. The distribution of food during conflict is uneven and often insufficient. Conflict often results in walls, if not actual walls, political walls. And whether real or political, barriers inhibit the free trade of resources. The conflict between Israelis and Palestinians has an origin in the conflict over access to water. Water is scarce in the Middle East, and access to aquifers and the Jordan River fuel the conflict. And lastly, for socio-political influences on the status of resource, consider population size. Large populations put greater pressure on resources than small populations. Now let's look at the intersection of resource status and the environment. Dramatic environmental degradation, like a nuclear accident, changes the status of uranium as a choice for energy. As a result of the nuclear accident in Chernobyl, 1986, and Fukushima, Japan, 2011, societies are skeptical about nuclear power. For example, there has not been a new nuclear reactor built in the United States since the early 1970s. Interestingly, as climate change has become more and more prevalent, and this is climate change that results from the carbon dioxide emitted from the burning of fossil fuel, the societal interest in nuclear power has increased because the generation of nuclear power emits no carbon dioxide. In evaluating the value of one resource or another, we must weigh the risks of a nuclear accident in the use of uranium with the risks of climate change in the use of fossil fuel. Renewable, non-polluting energy forms may have more value when people acknowledge the environmental damage from climate change caused by fossil fuel combustion. Historically, water in the world's streams and rivers was clean enough to drink. Not anymore. As a result of water pollution, societies spend a lot of money to clean water, and even then, many people choose to drink bottled water rather than what's available from the city. What are the environmental consequences of choosing water in plastic bottles rather than out of the tap? Could we better manage our resources to avoid environmental degradation? And McDonald's, a cultural force, has replaced plastic bags with paper bags. Now evaluate this. Paper versus plastic. Paper bags come from a renewable resource, but McDonald's puts bags within bags within bags, too many bags. And as you know, renewable resources can be managed in an unsustainable manner. And that brings us to the end of IB ESS Intro to Resources Part 4.